In this video, we're going to look at polynomial inequalities, and they're going to be similar to a polynomial equation, which if we look at the first example here, we have x squared minus 6x plus 9. Instead of equal to 16, we have less than 16. So now we're looking at what values of x are going to make this less than 16. Well, just like solving a regular polynomial equation, we're going to start off here by setting this inequality to 0. So that means we want to subtract the 16. So x squared minus 6x. And if we subtract 16 from both sides, then we would have 9 minus 16, which would be a negative 7 is less than 0. So that's your first step. We want to set this polynomial inequality to 0. So we want to figure out what values of x is going to make this less than 0. Well, I'm going to start this a little different. I'm going to actually look at the graph of this polynomial first and see if we can kind of explain what we're going to do more algebraically. So if we go to the calculator, go to y equals, we can type in x squared minus 6x minus 7. And I'm going to go to zoom 6, which is zoom standard. And that means we're going from negative 10 to 10 on the x and the y axis. And of course, we know we get our nice parabola here. Now, I'm not going to worry about zooming in, or zooming out rather. I know the parabola is going to continue, but I'm concerned more about what's happening above the x-axis and what's happening below the x-axis. So let me go ahead and copy this. So if we look here, thinking about this inequality here, we're looking at values that are going to be less than 0. So if we look at the graph, then that means we're looking at where is this graph less than 0? Well, if we look at the point here at, it looks like this would be a negative 1, it is equal to 0, and over here we can see at 7 that the graph is also equal to 0. So if this was a polynomial, for example, equation where we just had x squared minus 6x minus 7 equals to 0, if you were to factor this, you would end up with the factor here, which would be x and x, 7, 1, and we would need what, a negative 7 and a positive 1. So if we set these equal to 0, we would get x equals 7 and x equals negative 1. So that's where the graph crosses the x-axis. Well, for our problem though, we're not looking at values that are equal to 0. We're looking at where the graph is strictly less than 0. Well, that's going to occur anywhere here, and we know this is going to come down here somewhere, continue, and all the way back up to here. So what values of x are going to make this less than 0? Well, we identified this as negative 1, this point as a positive 7. So it looks like any values from negative 1 to a positive 7 would give us negative values down here. So therefore, the solution to this inequality would be any x value that is greater than negative 1 but less than a positive 7. So we can actually write that as interval notation, negative 1 to 7. Now, if you notice here, I actually am using parentheses for the notation because the endpoints negative 1 and 7 are not included. And once again, another way to write this would be negative 1 is less than x is less than 7. So either one of these notations would be fine. I think a lot of times you're starting at this point to use this interval notation of parentheses -1 to 7 parentheses, but this is the same thing as stating -1 is less than x and x is less than 7. Okay, so this is kind of a graphic view of what we're looking at. So now let's look at this same problem, but instead of looking at the graph here to determine the values of x, let's look at how we can do this from more of a algebraic standpoint. So I'm going to go ahead and bring down the inequality here, which would be our x squared minus 6x minus 7 is less than 0. So the first step again is we want to set the inequality to 0. So we've already done that. And then we're actually going to factor and find out what is basically going to make this 0. So we're going to factor just like we would normally. And we did this above, so we know this is going to be x minus 7, and this is going to be x plus 1. And again, if we set these equal to 0, x minus 7 is equal to 0, x plus 1 is equal to 0. So we know we're going to get x is a positive 7 and x is equal to a negative 1. Now, from before, looking at the graph, and let's see if we can bring the graph up here again. We notice these are what we're going to refer to as kind of our critical values, our key points that we're looking at is 7 and negative 1. This is basically where your graph can change from negative to positive. And certainly if we look over here at the graph, this is where our graph is equal to 0. So this is giving us kind of our key points. So algebraically from here, we would use this to set up our test intervals. So basically what that is telling us is we need to look at the interval here from negative infinity up to this point, which is negative 1. So we would look from negative infinity to negative 1, and then we need to look from negative 1 to 7, and then we need to figure out what's happening from 7 all the way over to positive infinity. So basically these kind of key points that we just found here, they're going to tell us where the graph could possibly change directions. So that's why we use those to set up our test interval. So basically here, notice we had these 2 points, so that's going to give us basically 3 different intervals. We're going to have here and over here. So we have to the left of the point, in between the 2 points, and to the right of the second point. So we need to test those to find out what is the value going to be. So we need to pick a test value within the interval. So the value I want to pick has to be somewhere from negative infinity to negative 1. So that means you could basically pick anything less than a negative 1. And to keep things simple, I'm going to pick a negative 2. And from negative 1 to 7, I'm going to make that easy and pick 0. And from 7 to infinity, I'm simply going to pick 8. So all I'm doing here for the test value is I'm picking some number within this interval, which here I use negative 2. And here I used 0, and then over here I used 8. So you can pick any number in that interval. Now, what we want to do with the test value is we want to plug that into the polynomial x squared minus 6x minus 7. So if we do that, we want to figure out what is going to be the value of the polynomial. Now, if you have your graphing calculator, you could simply use it from here. And since I've already have the polynomial x squared minus 6x minus 7, we could certainly plug in the negative 2 by hand, square the negative 2, multiply by negative 6, and subtract 7. But we already have this in the calculator. So I'm going to go second graph, which is into our table. And that way we can enter the values that we want. Now let's see, if I first of all go to second window is the table setup, and I want to scroll down where we have the independent is ask. So then if I go into the table, notice now it's going to let me type in the value of x that I want. Well, the x value we wanted is negative 2, and we get out a positive 9. So when x is a negative 2, our value is 9. What happens when we plug in 0 and 8? Well, if we plug in the 0, we get negative 7, and 8 is a positive 9. So we get negative 7 and a positive 9. Now, what conclusion can we make from this? What is our conclusion here? Well, what we're concerned with is not so much that this number is a 9, but we know that it is positive, and then we have a negative 7, and then we have a positive 9. And what that tells us then is for the solution for the inequality, then we're looking at values that are what? Less than 0. So that means if we're looking for values that are less than 0, we're looking at where are the values negative. And that's going to occur on the interval then that's listed here from negative 1 to positive 7. So our solution is negative 1, whoops, not negative 7, negative 1 to positive 7. Now, once again, because the inequality is strictly less than right here, we only look at the values between a negative 1 and a positive 7. So that's how we could list our solution. Now, also, another way that we could write this solution is to look at graphing the solution. So for example, if we have a number line, we could say we're looking at from negative 1, and we'll say here is positive 7. Then the solution would be simply parentheses at negative 1, parentheses at 7, and we would highlight everything in between, indicating x can take on any value between negative 1 and positive 7. So once again, if we go back to the graph, we can see if we're going from negative 1 to positive 7, all of the values that we get out would be negative values. So therefore, this is our solution. All right, what would happen if I take this same problem? I want to look at the same inequality, but now instead of using x squared minus 6x minus 7 is less than 0, let me quickly look at what would happen if this happened to be x squared minus 6x minus 7 is less than or equal to 0. So how would this change the problem? Well, the only difference is now when we go to look at our solution, we're now going to include the endpoints here of negative 1 and positive 7. So a lot of times you probably would think then if we're including that, that means we're going all the way to those endpoints. So then to identify the solution, we would go negative 1 to 7, but instead of using parentheses, we would put a bracket around the -1 and 7, because the bracket would indicate that we're going to include the endpoints as part of the solution. Just like if we were to write this answer this way, we would say -1 is less than or equal to x is less than or equal to 7. So here, just like the less than or equal to here, the equal to part means the -1 is included. That is the same thing as the bracket up here. So again, if this is less than or equal to, then we would use a bracket for the 7 as well. Up here, notice we simply use parentheses for the -1 and the 7, and that is because our inequality here was strictly less than. Okay, so that would mean then, because we are using less than or equal to, that means the solution then would be including the points here equal, and then also all of the points or all the values here that go down and back up to +7. So in the next couple of videos, you'll see some more examples of polynomial inequalities, and keep in mind we're looking at all of the values that are going to be either less than 0 or possibly less than or equal to, or greater than or equal to 0.